Today we're going to be learning about solubility, and we're going to be working on pages 12 and 13 in our interactive notebook. The first thing that we're going to look at, though, is we're going to look at what solubility means. Solubility is the ability to dissolve, and so we get meaning dissolve, and ability meaning the ability to. So solubility is the ability to dissolve, and the amount that's able to dissolve is very dependent upon temperature. It also can be dependent on particle size. It can be dependent upon whether you're stirring it or not, and also the pressure that you put on the system. But the most important factor, and the one that we're going to focus on today, is temperature. Now, you already know this. If you're trying to make sweet tea, you know the hotter the water, the more sugar you're going to be able to dissolve in it. The same thing as, if you take a can of soda that's got the gas dissolved inside of it and you leave it in the refrigerator, it'll stay fresh or carbonated longer than if you leave it out on a warm day. The hotter it is, the more flat it's going to become. But we're going to look at that in terms of graphs. So we can see that here on the x-axis we have temperature in both of my graphs, and on the y-axis I have the amount dissolved. And that would mean the amount of solute dissolved in solvent. So for example, the amount of sugar I'm going to be dissolving in hot water to make tea. Whenever I have a solid solute like sugar or salt or something like that, the hotter the temperature is, the more I'm able to dissolve. And so that's a direct relationship. When I increase the temperature, I increase the solubility. Now the opposite is true for gases. Solids and gases are opposite in their relationship between temperature and solubility. With a gas solute, the hotter it is, the less I'm able to dissolve. And so that's an inverse relationship. When temperature increases, solubility decreases. And this is really important in terms of biology, because we know that the warmer the water, the less oxygen, dissolved oxygen, it's going to be able to hold. So if you're a fish like a trout and you need a lot of oxygen, you're going to live in a place that is very cold so the water can hold a lot of oxygen. If you're something like a catfish and you don't need as much oxygen, you're going to be able to live in a place that's warmer because you can live on less dissolved oxygen. And so that's the idea behind solubility. Okay, now that we know the idea behind solubility, we're going to put this to work. And I'm just going to show you a preview before we get to our worksheet. With solubility curves, again, you can see we have temperature here on the x-axis, the amount dissolved in grams on the y-axis. There's a couple of different areas that we can describe within our graph. Okay, the first thing we need to see is we need to see the curve. This is the actual curve. So let's say that we're saying that this is for NaCl, or for sodium chloride in water. We can see that as the temperature is increasing, the amount that can dissolve is increasing. So this must be a solid solute because it has a direct relationship. Okay, right here on this line, at any given temperature and amount, this is what we would call saturated. So the line is a saturated solution. That means that it's the maximum amount. So saturated means the maximum amount. Maximum amount of solute is dissolved at that given temperature. So we can see at 30 degrees Celsius, the maximum amount of solute that I can dissolve, or the maximum amount of NaCl that I could dissolve, would be 50 grams based on this solubility curve. And that's because it's saturated. If I drop the temperature down here to 15 degrees, I can see that it would be more like 25 grams. If I bring the temperature up to 45, it would be more like 85 grams for saturation. But I don't always have exactly the same amount. Let's say that instead at 30 degrees I'd only put in 30 grams. So I'm going to meet up with 30 degrees and 30 grams, and I see that that point would be right here. Well, I can see that that is below the amount that should be able to be there. 50 is what it could hold at 30 degrees, but I only put in 30. So that would mean that the solution was unsaturated, or less than the maximum amount, meaning that I could still add more. Well, how much more would I need to add? If I was holding 30, and at 30 degrees, I could put in 20 more to be 50. But let's say I have a different situation. Let's say at 30 degrees, I put in 70 grams. Well, at 30 degrees, it can only hold 50. So if 30 degrees, I go up to 70, I see that I am above the line. Anytime I am above the line, that is supersaturated, and that means that I'm going to have a precipitate form. Some of it is going to trickle down to the bottom of the container. So if this is my container, and I have my liquid in here, some of it is going to be at the bottom in the solid form because I've put too much into it. How much would be at the bottom? Well, it can hold 50, but I put 70, so 20 grams would be down here at the bottom because that's what I put that was over the maximum amount or over the saturation point. Okay, so let's turn in our notebooks and let's go to pages 12 and 13. If you look at page 13 first, you should see a graph. It looks like this. And I just want to remind you, we have temperature here on the bottom, we have grams of solute here on the side, and this is a combined solubility curve. So we have lots of different compounds. Now I went in and I highlighted them different colors so they'd stand out to us. So we can see NaNO3 and KNO3. I noticed that for the most part, as temperature increases, the amount that is able to dissolve increases, with the exception of a couple of compounds. NH3, as it gets hotter, it decreases. That's ammonia. It's usually a gas, so that makes sense. And then I also have this Ce2SO43. It decreases as the temperature increases. So that probably is also a gas. But we know, in general, whenever the temperature increases, the amount increases for a solid. Okay, so let's look at a couple of our problems so we can best understand how to read solubility curve. So we're going to be on page 12. And let's start with question number 6. Question number 6 says, how many grams of ammonia chloride, or NH4Cl, will dissolve at 50 degrees Celsius? So all I have to do is come down here to 50 degrees Celsius and then go up to wherever the curve is for NH4Cl, which is right here. So at 50 degrees Celsius, I go up until I hit the line, and I can see that that is 50 grams. So at 50 degrees Celsius, I can hold 50 grams. So that's what I'll put in as my answer for number 6, 50 grams of solute. Okay, so let's look at number 7. Number 7 says blank and blank have the same solubility at 80 degrees Celsius. 78 degrees Celsius. So let's go to 78 degrees Celsius, which is going to be right here. And I'm going to slide up my line, and I'm going to see, where do I have two lines that cross? Well, it looks like right here, NaCl and KClO3. They both seem to be able to hold about 38 grams, 39 grams of solute at 78. So my answer would be NaCl and KClO3. NaCl and KClO3. Okay, so let's look at number 8. What compound is least soluble in water at 10 degrees Celsius? So I'm going to go to 10 degrees Celsius and I'm going to see who is lowest on the map. Well, that's this one that I've outlined in black, KClO3. It has the least solubility. KClO3. Okay, let's skip to number 10. Number 10 says, are the following solutions saturated, unsaturated, saturated, or supersaturated? Well, I know that unsaturated is going to be below the line, saturated is going to be on the line, and supersaturated will be above the line or above the maximum amount. So it says 45 grams of NaNO3 and 100 grams of water at 30 degrees Celsius. It is kind of important to pay attention to how much water are you looking at. If we notice on the side, we always know that it is here per 100 grams of water. So since that matches, I can just take my 45 grams of NaNO3. So I'm going to come here to 45 grams, and I'm going to look at NaNO3, and temperature was at 30 degrees Celsius. Now this is temperature dependent, so I'm going to focus on 30 degrees Celsius. So at 30 degrees Celsius, NaNO3 is able to hold 95 grams. But my problem says I only put in 45. So since I am below the line, my point is here, since I am below the line, I must be unsaturated. So my answer would be unsaturated. I could hold 95 grams, but I only put in 45. So since I'm below that, I'm unsaturated. Let's look at B. 60 grams of KClO3 and 100 grams of water at 60 degrees Celsius. So now I'm going to go to 60 degrees Celsius and see how much KClO3 I should be able to hold. So at 60 degrees Celsius, I go up to KClO3, and KClO3 is this black line, and it looks like I can hold 25 grams. For KClO3 at 60 degrees Celsius, I'm saturated at 25 grams. So I'm just going to jot this down to the side. 25 grams is saturated. Well, I put in 60 grams. Well, 60 is much bigger than 25, so I would be super saturated. I would have more than the normal amount available to dissolve. Okay, let's look at number 11. How many grams of sodium chloride, or NaCl, are required to saturate 100 grams of water at 100 degrees Celsius? So I'm going to go to 100 degrees Celsius. I'm going to go up to NaNO3, and I can tell if I kind of assume where the graph is going to go, it's going to be about up here. So if that's 140, 150, 160, 170, probably 170 grams. That was kind of tricky because it doesn't show up on our curve, but we can assume, kind of following the trend for, I totally lied, that's NaNO3. We're looking at NaCl. So sorry, let's go over that one again. Let's look at number 11. Number 11 says how many grams of sodium chloride, or NaCl, are required to saturate 100 grams of water at 100 degrees Celsius. So we're looking at NaCl. I just made a common mistake in that I found the wrong compound. So NaCl. At 100 degrees Celsius, NaCl is 40 grams. So at 100 degrees Celsius, I am saturated at 40 grams for NaCl. So we'll write that down, 40 grams. Okay, let's look at number 14. At what temperature would 25 grams of potassium chlorate, or KClO3, dissolve? So I need to know how hot does it need to be to get 25 grams to dissolve. So let's find KClO3. It's here, it's the black line. Let's go to 25, and we're going to slide over until we hit the line. So at 25, it looks like we're going to hit the line right here. What temperature is that? 60 degrees. So at 60 degrees, I could dissolve 25 grams of KClO3. So my temperature to dissolve 25 grams will be 60 degrees. Okay, let's look at number 16, and then we'll look at number 17, and we'll flip over to the back. Number 16 says 89 grams of NaNO3 is prepared at 30 degrees Celsius. Will all of the salt dissolve? It's basically asking me, is it going to be unsaturated, saturated, or supersaturated? So let's see, 30 degrees Celsius, NaNO3. At 30 degrees Celsius, NaNO3 can hold 95 grams. So that's going to be my saturation point, 95 grams. Well, I put 89 in, so will all of the salt dissolve? Yes. Could I still add more? Yes. What mass of NaNO3 will dissolve at this temperature? 95 grams. So I could actually add 6 more grams and still get it to dissolve. Okay, 17. If 25 grams of NH4 is dissolved at 50 degrees Celsius, how many additional grams of NH4Cl would be needed to make the solution saturated at 80 degrees? So basically what I'm doing is I'm taking a solution at 50 degrees and then I'm going to heat it up to 80 degrees and I'm going to see how much more I need to dissolve. So let's see, 50 degrees for NH4Cl. 50 degrees for NH4Cl, it is saturated with 50 grams, like it said, I'm sorry, it is saturated at 50 grams, we've only put in 25. Okay, if I continue to heat it up to 80 grams, how much more, 80 degrees Celsius, if I heat this up to 80 degrees Celsius, how much more can it hold? Okay, so let's see, NH4Cl at 80 degrees. Well, at 80 degrees, NH4Cl can hold about 65 grams. So at 80 degrees, it can hold 65 grams. If I only put 25 grams in there, how much more would I need? How many additional grams? So in order to go from 25 up to 65, that would be 40 more grams, right? To go from 25 up to 65, I'd have to add 40 more grams. So I'd need that many additional grams. Okay, let's look at the back of this worksheet, IMB 12, and we're going to read this chart. This is very similar, but this we're going to tell, is it saturated, unsaturated, or supersaturated? And then if it's unsaturated, we're going to say how much more can we dissolve. If it's supersaturated, we're going to say how much of it remains undissolved or as a precipitate at the bottom of the container. Okay, so let's see. A solution that contains 70 grams of NaNO3 at 60 degrees Celsius, and we're still talking about 100 grams of water. Okay, what I like to do is I like to just say what it's saturated at. So we always look at the temperature, 60 degrees Celsius. Let's look at NaNO3 and let's see how much it could hold. So NaNO3 at 60 degrees Celsius. Well, at 60 degrees Celsius, NaNO3 can hold about 123 grams. So I'm just going to jot that down. 123 grams is what would be saturated for 60 degrees. Now, we've only put in 70 grams. So if we put in 70 but it could hold 123, it must be unsaturated because we have less than the normal amount. Okay, so if we have less than the normal amount, it can hold 123, we only gave it 70. How much more could we put in? Well, we could put in 53 more grams. So let's look at the next one. A solution contains 70 grams of NaNO3 at 30 degrees Celsius in 100 grams of water. Okay, so we're going to look at NaNO3 at 30 degrees Celsius. We're going to write down what it would be saturated at. NaNO3, 30 degrees Celsius. It is saturated at 95 grams. So we'll add 95 grams is what it can hold. We've only put in 70 grams. So am I above or below my saturation point? Below. So that would be unsaturated. And then I put in 70, so how much more could I put in? 25 grams more is what I could hold. Okay, let's look at this one. A solution contains 50 grams of NH4Cl at 30 degrees Celsius. So now we're moving to NH4Cl and we're looking at 30 degrees Celsius. NH4Cl at 30 degrees Celsius, going up to the red line here, it kind of intersects with a lot. Looks like I'm at 40 grams for NH4Cl at 30 degrees. 40 grams. So my saturation point is 40 grams. Well, how much did I put in? 50 grams. 50 is above my saturation point. So that means that I'm going to have a supersaturated solution. There's going to be extra. How much extra? Well, let's see. I could hold 40, but I put in 50. So what's the difference between those? 10 grams. So 10 grams extra, or 10 grams is going to fall to the bottom of my container. Okay, last problem. A solution that contains 50 grams of NH4Cl at 60 degrees Celsius. Okay, so NH4Cl, 50 grams, 60 degrees Celsius. 60 degrees Celsius, NH4Cl, 55 grams. It could hold 55 grams. So saturated would be 55 grams. I put in 50. 50 is below my saturation point, so it would be unsaturated. And how much more could I put in there? 5. 5 grams more. So you'll notice here, every time it's unsaturated, although I am subtracting my values, if it's unsaturated, I can add that much more. If it's supersaturated, I have the difference extra. Supersaturated will always have extra. Unsaturated will always have more that it can hold. And this is how we find solubility. Remember, again, that solubility is the ability to dissolve. It's dependent upon temperature, and it varies for solids and gases. Solids have a direct relationship. Gases have an indirect relationship between temperature and solubility. And we know that on the line, it's saturated, but above the line at any given temperature, it's supersaturated. Below the line at any given temperature, it is unsaturated. Saturation means the maximum amount of solute that will dissolve at that temperature.